Welcome to this video. We are going to solve some problems on data analysis from Topic 1 in IB Physics SL. This is the new curriculum, the one where the first test will be in 2016. That's next year for those watching the video this year, which is 2015. Okay, question about electrical resistance, but that won't actually matter. The graph shows the variation with temperature of the resistance R. In other words, as you vary or change temperature, how does R respond for a particular electrical component? A student hypothesizes that the resistance is inversely proportional to the temperature. After all, that's kind of the shape of an inverse graph, a reasonable initial hypothesis. Use data from the graph. Aha! They're not asking to state evidence, they want us to use data from the graph to show whether the hypothesis is supported. Whenever they say that, they mean use one of your 2-point tests. It's either the ratio test or the, what's the other one called? The product test. Ratio is for direct proportionality, product is for inverse. Our hypothesis is inverse, so we use the product test. Choose 2 points. I'll take this one here, and that's easy. It's on the grid line, right? And it's right between these two. And then I'll choose another point. Let's see, I'll take this one. It's right between those 2 grid lines. Oh gosh. And it goes down. And use those points, the data, to show whether or not this hypothesis is supported. First, you find the values, the coordinates of this point and that point. And let me show you how to do this. Well, we've already learned, right? You trace over, you think, okay, from here to here is 1,000, and how many times do we subdivide it? There's 1, 2, 3 boxes, 4, 5 boxes, 6, 7, 8, 9, 10 little boxes. So these minor tick marks are worth 100. Okay, so 4,000, and I've got 4,100, 42, 43, 44, 45, 46, 47. This is 4,700. This is 48. And right between 47 and 48 is 4750. So that's the Y value, right? 4750. And then the X value is halfway between 250 and 300. Right? This is 2 blocks from 250, 2 big blocks, and 2 big blocks from 300. So halfway between 275. Okay. Then we come to this point. We go over and let's see. Oh yeah, each little tick mark is 100. So we have 100, 200, and then half, which is 250. 250 is that. I like putting the coordinates on the graph. And then go down and we are, let's see, 350. And then we have a big block, 1 big block, 2 big blocks, 3, 4 big blocks. From 350 to 400 is 50. We've divided it into 4 big blocks. And what's that? 12 and a half. So each of these tick marks is 12 and a half. So right here, we have gone 12 and a half more than 350. So 12 and a half plus 350. And this is 362.5. Excellent. We're finally ready to do the work. That's the hard part, right? All right. So we do the product test because we're testing for inverse. That means multiply, take the product of these 2 values, R and T, to see if they're inversely proportional. Do it for this point. Multiply the 2 values, R and T, for this. So R1 times T1 is going to be, let's do this one first. Which was R? This is R. 4750 times 275. And then down here we're going to do R. The R value was, well, this is embarrassing. I flipped these 2, haven't I? Gosh. Maybe don't write coordinates down. The resistance value is over here, 250. It's x comma y. Oh gosh, okay. Pretend you don't see this. No, but we have to see it because we're solving. All right, just flip those in your mind. Have I done this correctly? No. R should come first. Long day, right? You guys know the feeling. So you calculate each of these things. Let's do that right now. 4750 times 275. What a big number. 1306250. There's no way 250 times that is equally big. So, but we'd calculate anyway, even though we can guess the answer. And we get 90,625. Okay. We describe what we see. The product of R and T is not a constant. Then we conclude. Thus, R and T are not inversely proportional. Sorry, Mr. Student, you didn't quite get it right. A good guess based on the shape, but further analysis shows not so. Okay. What could be the relationship? Well, a second student comes along and suggests that this is the relationship. What a mess this is. Log of R is equal to A plus B over T, where A and B are constants. And then the student makes a graph, a very clever graph. Log of R against 1 over T. Can you see that there? Log of R against 1 over T. The units for R are ohms, and when you take the log, the units disappear. We pretend they're not there. But R itself has units, but the log of R is dimensionless. And then 1 over T has units of Kelvin to the negative 1, but every value on this axis has to be multiplied by 0.001, or by 10 to the negative 3. Make sure you remember that. Oh my gosh, easiest thing to do. I'm going to star that like a billion times because it's so important, and I will forget. In fact, this is the second time I've made this video. I forgot the first time. Oh, infuriating. Okay. The first thing to notice, log of R is on the y-axis, so write this equation again, but replace log of R with y. B over T can be rewritten as, let's see, B times 1 over T. And why did I do that? Well, because 1 over T is my x-axis quantity. So this is equal to x. I rewrote my equation. I replaced what was on the y-axis with y, and 1 over T, which was on the x, became an x. And we see now this has the form, if you just rearrange, switch these two, it has the form y equals mx plus b. That's the straight line equation. Okay. And look, explain how the graph could be used as evidence to support the suggestion. Here's your evidence. The equation has the form of a straight line. When you graph log of R against 1 over T, does it make a straight line? Sure looks like it. Let's draw a best fit and see if it goes through all the error bars. Clearly it's going to go through all the error bars, right? Do it pretty good. And I'm going to have to extrapolate back. So I'm going to go ahead and do that now. Extrapolate it all the way back. How am I doing? Maybe like that. That's decent. Oh gosh, I need a longer ruler. Alright, I make sure it's lined up. I kind of like to retrace again. There. Okay, that's a decent line of best fit right there. I'm very close to all the data points, well within the error bars, and there's, 2 data points above and 2 below. So I'm doing pretty good. This up and down is just kind of random error. Alright then, put this into words. Oh, look, I started this a while ago. Don't forget it.